The first practice problem that we're going to do is x equals 5. For all these problems, we're going to graph them on polar graph paper, and we're going to convert them into a polar equation. Okay? So for most of these problems, they are easier to graph when you look at them in rectangular form like this. So if you look at this equation, it's a line. What kind of line is it? It's a vertical line. A vertical line at x equals 5, okay? Now the part that's going to make this difficult to graph is that instead of graphing it on normal graph paper, we're going to graph it on this. And so it's not hard, it just messes with your brain because there's too many lines on there and you're trying to graph something that's vertical on something that's circular, and that's hard for your brain to handle, okay? So on the graph paper, we're going to label number 1. And I'm going to count to the right, 1, 2, 3, 4, 5, and I'm going to draw a vertical line. So that's the vertical line, x equals 5. Messes with your brain, right?
You said don't write this in your notes or do write this in?
This is not notes, this is your assignment. We're just starting it together. Yeah, r equals 5. Or not r equals, sorry, x equals 5. Okay. Now we're going to go ahead and on the notebook paper, we're going to convert this into a polar equation. All right. So what are some of the formulas that we learned this unit?
With the r equals
So we have x equals
r cos theta.
And we have y equals
r sine theta.
And we have x squared equals, sorry, r squared equals.
Squared plus y.
Yeah, let me erase that. X squared plus y squared. What's an alternate form of this exact same equation? So r equals square root of x squared plus y squared. And we have tan theta equals y over x. And the alternate form is theta equals tan inverse of y over x. Okay. So those are the 4 formulas that show up a lot. These are not like you should put it on your cheat sheet so that you can remember it later, but these are not just cheat sheet formulas, these should be memorized. Because if you try to use your cheat sheet in the last 15 minutes and you don't have these memorized, then you're going to have to do your test in 15 minutes. Okay?
You talking about Friday?
Yeah. So you got these 4 formulas need to be in your brain.
I got 2 of them.
On your cheat sheet as a backup, but they got to be in your brain. Okay? So we use them for coordinates, we use them for equations, we use them at the entire unit. All right? So here we have an x equals 5. What formula am I going to use to substitute? R cos theta. So I'm going to say r cos theta equals 5. And if you recall from the video, we make our substitutions, we get our recognizable equation. And recognizable equations in polar are kind of hard because we don't really deal with polar like we haven't before this unit. So polar equations are always in the form r equals something. There's one exception to that. We'll do that in a little bit. But for the most part, they're r equals something. So how do I get the r by itself? I divide the cos over. So I'm going to say r equals 5 divided by cos. That's the polar equation. That's it. There's an alternate form of this, 5 times secant theta. How did I get that? Yeah, 1 over cos is the same thing as secant. So you don't have to write both answers, but these are both valid equations.
So why didn't you do cos inverse?
Because cos inverse would have gotten the theta by itself. It wouldn't have gotten rid of the cos and the theta. I wanted the cos and the theta to go to the other side. Okay. Problem 2. We're going to do y equals negative 2. What kind of equation is that?
That's horizontal.
That's a horizontal line. Okay, so on your polar graph paper, we're going to write number 2. And y equals negative 2. We got a horizontal line at negative 2. I tried. Why are you so judgy?
Stop touching your water bottle.
All right. So we got our line drawn. Now what do I do to convert it?
You do R sine theta.
R sine theta, that's an N, I don't know what I did there. R sine theta equals -2. And then what do I do? Yeah, divide the sine over. So R equals -2 over sine theta. Or, what's the alternate form?
R equals -2 cosecant theta.
Yep. Why is there so much language while I'm making a video? Goodness.
We didn't know you was recording.
I did.
See, you don't make it no better.
All right. We're going to do one that's a little bit more difficult. Okay. We're going to do x minus 2 squared plus y plus 2 squared equals 8. So this is different than the ones that we had on the video notes even. Because the video notes would have had like x minus 2 squared plus just y squared, right? But if you look at your notes, what was the first step? Don't ask Siri. She will have a confusing answer probably. So if you look at your notes, what should we do next? Well, so we would make substitutions first and then do that. But before we can even make our substitutions, we have to do something. Yeah, we're going to kind of expand it out because if we make our substitutions right away on this problem, it makes it a little bit more difficult. So I'm going to go ahead and expand it out so that I can see if I have an x squared plus a y squared, because I know that becomes r squared. And so that I can have my x's and my y's. It'll just make the problem a little bit easier if I do this first and then make my substitutions. Okay, so what do I do with these two parentheses next to each other? I FOIL them. So I've got x squared minus 2x minus another 2x plus 4. And then I have y squared plus 2y plus another 2y plus 4. So what I'm doing right now is I'm converting this equation from being in that standard form of a circle, right? In the standard form of the circle, you can see what the center of the circle is, and you can see what the radius is. I'm converting it back into that general form, because then I can see each individual term and I can move them around if I want to. So what I'm going to do now is I'm going to write the x squared and the y squared next to each other, x squared plus y squared. And what's the benefit of being able to have both of those? What substitution do I have for that? That's r squared. So that worked out kind of nicely, right? And then we have a negative 4x, and we know that we can substitute for x. So that one's pretty good. And then we have a 4y, and I know that I can substitute for y, so that's good. And then right here, I have 4 plus 4, which is 8. And I have that 8 right there.
So that's 0.
So it's going to be 0. If I tried to subtract them all over to the right side, it would give me 0. Or if I subtracted that one over to the left side, it would give me 0. Okay? So all these numbers basically like cancel out, and this equation just equals 0. And the reason that works out well for us is because we want to get rid of all of the x's and y's, and we want to only have r and theta. And right now we have something that we can substitute for all 3 of these terms, right? Well, 4 terms, but we got 3 things to substitute. So the x squared plus y squared becomes r squared. The negative 4x is going to become negative 4r cos theta. The 4y is going to become 4r sine theta. And it equals 0. Okay. So at this point, this is the part that's a little bit weird, but this is how I said we're always going to solve our polar equations when they're kind of like this. We make it equal 0. Yeah, we're going to factor it. So what do we take out?
R.
We take out an r. And if I take an r out of r squared, what do I have? R. And if I take an r out of negative 4r cos theta, what's left over? Yeah, minus 4 cos theta. And if I take an r out over here, what's left over? Okay, so this r right here is 0. And that doesn't do anything for us. I'll show you in a second where that comes into play in your graph. And then over here we have r equals, and remember it's always the opposite of the other part of the parentheses, right? It's always the opposite. Like if we had x minus 5 in our parentheses, we'd be like, oh, x equals 5. Or if we had y plus 3, we'd be like, oh, y equals negative 3. So if we have r minus 4 cos theta plus sine theta, 4 sine theta, then what's our answer? It's positive 4 cos theta. And then what else? Minus 4 sine theta because it's the opposite sign. So this is our polar equation. Now, we haven't graphed number 3 yet. We have 2 options. We can graph it from this equation up here in rectangular form, or we can graph it from this equation down here. Which one's easier to graph it from?
I'm guessing
The first one, because who knows how to graph that? I sure don't. Let's graph the first one. So the first one is a circle. What's the center of the circle?
2 negative 2.
Okay, the center of the circle is 2, negative 2. The radius of the circle is... No. It's the square root of 8. What's the square root of 8?
No.
Well, we're about to graph it, so let's go ahead and find the decimal, because that'll make it easier to graph. 2.8. Okay, so a little bit less than 3. Okay, so we're grabbing our graph paper. This is the one that's going to hurt your brain the most. We're going to go right to and down to. So when you use this, when you are drawing a rectangular graph on polar graph paper, you have to pretend that all you can see are these parts right here, and you ignore the rest of it. Okay? So all these curved lines and diagonal lines, we pretend we can't even see them. Okay? I'm going to go right to and down to. There's the center. Right to and down to. There's my center.
So you didn't count the
I'm not counting any other lines. So see, this is right to. This is down to.
Oh, so you're not counting the circle.
I'm not counting the circles. I'm pretending that there's like horizontal and vertical lines here. You guys see that? I'm like picturing them in my head. Okay? And then my radius was 2.8. So I'm going to go up 2.8 and right 2.8 and left 2.8. So what you have to do is you have to picture that there's like a grid here.
Yeah, I'm still not seeing it.
It hurts your brain. So if you need to draw out a little grid like I'm doing, then go ahead and draw a little grid there. So I went up 2.8 and right 2.8 and left. So the hardest part about this is you're pretending that there's an X and a Y grid like normal, but you can't see it. So you're always drawing everything based off just like starting here. So when I went right 2 and down 2, and that was right here. And then I counted from here up 1, 2, and a little bit less than that. And then from here I counted over 1, 2, a little bit less than 3. To the right I counted over 1, 2, a little bit less than 3. So I'm always counting based off of these lines. 1, 2, a little bit less than 3. And then here's my circle. Yeah. They're not fun to draw, but they're not impossible. This is not the hardest thing you've done this year, not by a long shot.
Can I just try the best I can?
Yeah, do the best you can. I mean, a certain amount of this is kind of eyeballed. But if your circle is like way too big or way too small, then I know you didn't do it. Okay.
Oh, Chelsea.
You go all up and down.
All right, so what I want you guys to do next is we're going to nose goes to get the textbooks.
Tyler.
Which textbooks, Miss Rice? These ones?
Not the calculus one.
You 4 books? Please. After class. I'll take
So on page 557, you guys are going to do 26, 27, and 28, and all 3 of those need to be graphed on your graph paper. Okay, 26, 27, 28, and you're graphing all 3 of them. So that's what we're working on right now.
I think it was going to be that loud.
All right, 26, 27, 28. 26, 27, 28 on your graph paper. All right, so after number 28, so on your paper, you should have 26, 27, 28. And now we're going to do number 4 of the class problems together. Okay, so number 4 is going to be x equals 1/2 y squared. X equals 1/2 y squared. And now when we're graphing this, we're on the back side of the graph paper.
Is that in the book?
No, this is the made-up problem that we're all doing together. Okay, so this is number 4 on our graph paper. On the back side now, because we've used all 6 on the front.
Number 4?
Yep, this is number 4 of the class problems. All right. Now, if this problem said y equals x squared, what type of equation would it be? Y equals x squared. What is that? No, don't convert it. Just what would we draw? Y equals x squared is a parabola that goes up. X equals y squared is a parabola that goes sideways. It would go down if it was negative x squared. It goes to the right if it's positive y squared. It goes to the left if it's negative y squared. So this parabola goes to the right. Okay? This one, we already can see, right? We've already done a few. We already know it's going to get harder to graph if we do it from polar form, so we can go ahead and graph it now. Okay? I know that if I plug 0 in for y, that 1/2 times 0 squared is still going to be 0 for x. So I know that the point 0, 0 shows up on the graph. So I have this point right here. What happens if I use a y coordinate of 1? I have 1/2 times 1 squared. What's my x coordinate? 1/2. Yep. So I'm going to go to the right 1/2 and up 1. What happens if I use a y coordinate of -1? What's my x coordinate if I plug -1 in right here? 1/2 times -1 squared is still just 1/2. All right, so that gives me the point 1/2 -1. Okay, what if I plug in a y coordinate of 2? 1/2 times 2 squared. 1/2 times 2 squared is 2. It's 1/2 times 4. So all right, what about if I plug in a y coordinate of -2? Then I would have 1/2 times -2 squared. It's still 2. So that'd be the point 2, -2. And at this point, I'm going to say that's enough to draw a sideways parabola. So we've drawn the picture of it. Now we can go ahead and convert it into polar form. Okay? That's okay. All right. So in the polar form, and you didn't need any of this technically, that was just us graphing it. Okay, so to convert it into polar form, I'm never going to have an x squared plus y squared because this problem does not have one. So I don't get to substitute r squared into the problem. All I get to use is that I know that x equals what? R cos theta. And I know I've got 1/2 times y squared. And what can I replace the y with? R sine theta. Okay. All right, so let's go ahead and multiply this part out. If I had r sine theta times itself, what do I get? R squared sine squared, right? R squared sine squared. If I did r sine times r sine, I get r squared and sine squared. Now remember, when we are writing a polar equation, we need the r to be by itself, and typically the way we do that is by factoring. All right, so what do I need to do so I can factor this equation? It needs to all be on one side. Do you guys want to minus this part over here, or do you want to minus that part over there? It doesn't matter. Okay, so we'll minus the r cos theta over. So 0, that's not a theta, that's a 0. 0 equals 1/2 r squared sine squared minus r cos theta. And this is when we factor, because we're isolating the r. Okay? So I'm going to take the r out, and then what's left over? I still got an r in this one, though, because I took out 1, but it leaves 1. 1/2 r minus cos theta. Okay. So this r equals 0. And this right here where it says r equals 0, it's just like, hey, if you look at your graph, it hits the point 0. And you go, cool. Thanks for letting me know. I don't care about you. Okay? Yep. It's rough. All right. And then this one over here, it's a little bit more difficult than just doing the opposite sign. So I'd say if you have to isolate an r in something that's messy like this, just take what's in the parentheses and set it equal to 0. because that's what we used to do back in the day. And then we figured out when you do the opposite sign, that's like the shortcut. I'm going to not do the shortcut on this one because I think the shortcut is confusing for this one in particular. So I'm going to say 1/2 r sine squared theta minus cos theta equals 0. And I'm going to get this r alone just by moving everything to the other side one thing at a time. Okay? So what's the easiest thing to move to the other side? The 1/2 is too close to the r to move it first. There's something else you can move first. The cos. Let's move the cos over. So that means I'm going to have 1/2 r squared, not r squared, r sine squared. Sorry. Equals, now I have the cos on the other side, right? Okay? Then what could I move over to the other side? I can move the 1/2. So how do I get rid of the 1/2? You could divide by 1/2, but it'd probably be easier to multiply by 2. Okay, so I have r sine squared. Yeah, I flipped it because I was running out of room. R sine squared equals 2 cos squared. Sorry, 2 cos. I'm sorry. I'm stressing out because it's the end of the period, even though we have 5 minutes, and I'm saying things incorrectly. Okay. And then I divide by sine squared. Okay, that's the equation. Do you see how we worked with that? So we still factored just like we did the other time, but it was a little bit harder to get the r by itself. And so instead of doing it in my head, I just showed my steps. Okay? All right, does that make sense? Yes. Okay. So your homework tonight is to finish the converting coordinates worksheet, and you did 26, 27, 28, so now you need to do 29 and 32 through 34. I will put those up on the website for you. Okay? So that is finishing the worksheet from the beginning of class and 4 book problems. 4. No video tonight. Finish the worksheet, 4 book problems.